in terms of development of the electric vehicle architecture, there are still challenges as we speak today in terms of material compatibility, where copper corrosion and the electronics and PCB circuitry in the EV architecture continues to be one of the big challenge for developers. In the electric conductivity, in terms of stray electricity, thermal management for thermal stability and heat transfer, and the topic of interest today where the tribological challenges in EV architecture, such as the stray and static shaft currents that's happening in the shaft in the bearing, as well as the need to develop new type of e-fluid formulation to meet the architecture of the electric vehicle. And all this development of the new e-fluids, they need to be tested, which motivated us to introduce electrified tribal testing to the industry. Why is it needed in terms of the electric tribal testing? We need that to test formulations of EV lubricants, such as the electrical contact resistance by applying electrical voltages to monitor the formation of tribofilm. At the same time, we would like to study as well the effects of lubricity due to a current flowing through when it contacts between the shafts and the lubricants in the EV. And how can we control lubricity by applying potential? So all these questions that we have can be answered if we were to test lubricants that's been formulated. The second motivation is we see that today there is no solid standard test protocols yet for electrified tribal testing. And lastly is that there is limited availability of commercially accessible tribometers capable of replicating electrified conditions. So having to put these three gaps together, we are here today to demonstrate recently developed testing methods using the Bruker UNT TriboLab, where the objective of today is basically for us to evaluate the friction and wear characteristics of commercial EV fluids tested in both DC and AC environments. We'll show some case studies that we have done. And subsequently, this would allow us to demonstrate the lubricant testing in an electrified environment on a commercially available tribometer, in our case, the Bruker UNT TriboLab. So without further ado, allow me to introduce you to the instrumentation that we are going to use in this webinar. So to carry out there are different test methods that we can carry out or to simulate a driving condition in the electric vehicle using the UNT TriboLab. So as on the screen, we have the UNT TriboLab as the base tribometer, and we can configure that on the pin on this configuration, which we are going to show some of the relevant examples that we have done by flowing through some AC and DC current while carrying out some lubricant testing with some lubricants, of course. And secondly, when it comes to terms of greases in the bearing, we would demonstrate it using a 4-ball tester. And the third test method will be the block-on-ring method, which has been carried out by Lee et al. With further reference on this paper on the block-on-ring configuration on the UNT TriboLab. And for today's webinar, with our focus will be more on the pin on this and the 4-ball tester. So how do we look at how the test bench is going to set up for this test? We'll be using the Bruker UNT TriboLab with a rotary drive to simulate a unidirectional movement in a circular motion. And we will use a force sensor and a ball holder that is specially designed such that it allows the flow of the current, that's conductivity. We have a liquid holder that holds the disc, and at the same time it acts as a heater for testings that needs to be done at an elevated temperature that we will demonstrate some. And of course, we need a power source where we integrated a commercially available AC and DC power sources to simulate the test. Now, a complete setup of the test bench on the Bruker EMT TriboLab looks like over here, where we have a force sensor that will apply the downforce. And at the bottom here, there is the rotary drive with the with the heating chamber. And if we look over there in the heating chamber, this is how the upper ball holder with a ball which is inside, and the lubricant is about 12 milliliters is being poured inside. There will be holes in the liquid holder. Basically, that's for circulation when there's the rotary motion. We use a 4-wire measurement method. Basically, this is for this architecture. We are testing it with standard parts. The upper ball and the lower ball is basically standard. For this purpose of this test, using stainless steel alloy, and we test it using a commercial fluid. We tried to design some these test metrics for this electrified tribo testing purpose. So for the subsequent slides where we show some examples, the load is basically what we try is 90 to 120 newtons at a temperature of room temp, 25 degrees Celsius. We did some heating to see how that heating would actually affect friction and wear under electrified environment at 60 and 120 degrees Celsius respectively. The specimen that we'll be using over here is a stainless steel alloy E52100. We managed to get two types of commercially available ATF and fluid. So for our setup, we don't need to use a lot of fluids. Basically, as little as 12 milliliters will be sufficient to carry out a test that gives us a sufficient results to quantify the coefficient of friction and the wear at the same time. The sliding condition that we're applying is varying speed, basically up to about 5.8 meters per second. We let it run for 5 and 10 kilometers, depending on the test condition. For comparison purpose, we did the test under unelectrified condition, as well as to apply various direct current and also alternating current to the test. So without further ado, when we carry out some of the tests, a few practical application and experiments that I would like to share with you. Where the first case study, what we are trying to answer is whether or not does electrification affect friction and wear. Now, if we look at these slides over here, the results over here, where it will start with quite a heavy load. So this basically 120 Newton was chosen if we want to try to have a mixed region contact where there is a contact between the metal and the upper and the lower sample, as well as with the lubrication fluid. So as we can see over here, when we try to